All right, we're back on air. Brief review of what we've done. We worked out quiz question number 1. Just barely did all those. Yeah, pretty nice stuff. The range, we were just looking at that, me and Will. The range is -1 to 5. Period is 4 pi. Shifted to the right 3 pi over 2, and then raised 2 units with an amplitude of 3. And William, this is correct. You got the what was the equation that we ended up with that one?
We had y equals negative square root 21 over 5.
Yeah, and that one was for number 2. Yep. So number 2, we just did cosine A squared plus sine squared equals 1. Substitute for cosine A being 2 over 5. I squared that, so 4 over 25. All minus that, making it sine A equals plus or minus 21 over 5, and we'll submit the paper. So yeah, sine A is negative 21 over 5. And now we're working on number 3, which is doing great. All right. So I'm guessing we're just writing the fundamentals.
Well, we have to write 2 functions.
Yeah. Well, with what you showed me on the fundamentals, one of the functions for cosine is that cosine, in terms of sine, tangent equals sine over cosine, right?
Correct.
And so if we convert that and make it, let's see, 3 tangent equals, is it sine over cosine or is it cosine over sine?
Let me check. I want to say it's sine over cosine.
Yeah, sine over cosine.
Although those are the quotient identities. So we could also do an even odd identity or a Pythagorean identity.
Yeah.
Pythagorean one would be pretty simple. Sine squared plus cosine squared, both of them have an angle, equals 1.
And so it would be 1 minus cosine squared equals sine squared. That could be
Correct.
one that we use. Yep. So, because we have to write 2 formulas on that, right? That's what I'm kind of understanding.
And then we have to indicate which formula to use for a value of A.
Which formula to use for a value of A? For a
Yeah.
given value of A. I'd use this one. I'd use the Pythagorean theorem one.
Okay.
For which formula to use for a given value of A? Yeah. Let's see. Because the other one has cosine in there. Cosine of A equals sine A tangent. And so writing that in the relationship function is cosine squared of A equals 2 function for cosine in terms of sine equals 1 minus sine squared. Okay. Which formula to use for a given value of A? I think this question is definitely worded weird. Not weirded weird. Okay. For a given value of A for a given value of A. Oh, that's interesting.
Hmm.
So if it's cosine of A and it's sine of A, they should be equal to each other. Should be equal to or the inverse of each other.
Okay.
Or sorry, or the opposite of each other.
So would we do like a with Pythagorean? Would the angles then be like a 30, 60, 90?
30, 60, 90.
If you put in 30 and 60, would you get it out?
Yeah. Which formula to use for, yeah. I don't know what they're wanting us to do because I have for a given value of A, cosine of A equals 1 minus sine squared of A. Cosine squared of A equals 1 minus sine squared of A. And that's for a given value of A. And to get which formula to use for a given value of A. Just the normal formula.
So it's kind of doing like, it's like doing f of g of x. And we have to first do g of x with one of these. And then you.
Oh, okay. To write two functions, indicate which formula is used for a given value of A. Two functions of cosine A in terms of sine of A. So does that mean, in terms of sine of A, does that mean sine of A equals whatever cosine A is? Or does it mean cosine A equals whatever sine is? Or does that make any sense?
Yeah, I didn't follow that.
Yeah, I didn't follow it either. I came out of my own mouth and I didn't follow it. All right, so what are you thinking? Because I have this written down. It looks kind of weird. I don't think that's what they're wanting. So too simple.
Well, no. I think you got it. Because if you go equals cosine over sine or sine over cosine, whatever it was. And then if you do the Pythagorean one, and if the angles are 30, 60, so you have a 30, 60, 90, isn't that a 3, 4, 5 triangle?
So
if you 30 on cosine and 60 on sine, you should get the tangent angle, right?
Yeah.
So that's what you do. You do that and you get the tangent angle, and you can then plug that into the other one, and it inverses. They're proofs of each other.
Oh. Okay. So basically,
I mean, I think that's what I would do. I don't.
So we just show the example of the 30-60 triangle?
No, you just have to go like cosine 30 squared sine 60 squared equals
1.
whatever the equation was. I don't remember. Let me see. So you have tangent equals sine over cosine right now?
Uh-huh. And then I have the other one, the other function that's sine squared A plus cosine squared A equals 1.
Okay. Yeah, I don't know what else we would do. I'd go sine 30 cosine 60.
Yeah.
I guess it's in terms of A. So really you would just put in alpha for the angle, right?
Yeah.
You don't even need the 30/60.
Yeah. It'd be the same.
I think that's it.
It'd be the same numbers. It'd be like 45.
Yeah, it'd be 45/45.
Yeah, 45 each. So interesting.
I think we're good.
Yeah, let's go ahead and circle these two then. Just what I got here is two formulas. And then just, yeah, for a given value of A, cosine equals that. And then see what she says.
Okay.
Alrighty.
Sweet. Catch you Tuesday.
All right, man. Catch you Tuesday. I'll go ahead and get this submitted. Have a good one.
See ya.
Take care.